Okay, so now we're ready to start into chapter 2. And the first thing we do when we talk about chapter 2 is to talk about motion. So now we're talking about the idea of translation. So this is one-dimensional motion. So translation, one-dimensional motion. In chapter 4, we'll talk about two-dimensional motion. So in discussing translation, we want to describe going from here to there. So this is our initial spot, and then that is our final spot. And so we want to go from initial to final. And in discussing that, then we need to figure out, how do we do this, because at some point in time we're here, and then at some other time we're over here. So at some initial time we're here, and at some final time we're over here. Okay. So displacement is a measure of how much translation we did. So you have a spot here, You got to pick an origin. Okay, pick an origin. Have a line that runs through here, and so this is the final position right here. That's the initial position. So the coordinate, the x-coordinate, the final position, minus the x-coordinate, the initial position, that is your displacement, delta x. So the delta x is displacement. If we had started here, xi, and started there, xf, then xf is less than xi, so we would have had a negative displacement. So this would be a positive displacement. That's going to be a negative displacement right there. Now let's change a couple of variables here. Nice thing about algebra or calculus is it doesn't really matter what you call the variable. Your book uses multiple different symbols to mean the same thing. So we have, I've been using x final and x initial. The other thing we sometimes do is we just say, well, we know the initial is where you start. And so we're going to call that x sub 0, or we pronounce that x naught. So x naught is where you started. And at some time in the future, you are at x. Okay. And so x is just at some point in the future. So at some time in the future, you are at x. And so you started here at some time, you ended there at some other time, some later time. The difference in time, okay, so x naught, or your initial position, is like your x at some time t. Your final position x is at x at some time t plus delta t. So these are three different ways of writing displacement right here. Displacement has sign. We just talked about plus and minus. So I put my origin here. Okay, I started there, I ended there. So this is my x naught, that's my x, my final position. And so in that case, then the x is positive. But wait a minute, what if I put my origin here like that? Okay, now that's x naught, that's x. Well, now if my origin is right here, if I say that way is positive, this number is more positive than that number, so delta x is going to be negative. Okay, so what is this? They both moved in the same direction, but here I said this is positive and this is negative. How can I have positive and negative displacement that's really the same thing? Well, it has to do with your coordinates. You pick an origin and you pick which direction's positive. If it's moving in the direction you said was positive, that's positive displacement. If it's moving opposite direction you said was positive, that is negative displacement. It doesn't really matter where you put the origin. If you have a ruler, you can lay the ruler down one way or lay the ruler down the other way, and you're going to get numbers going bigger one way or bigger going the other direction just by how you set the ruler down. And that doesn't really change any of the measurements. It just changes how you hold the ruler. And so that would make the final number either bigger or smaller depending on how you placed your origin. So this becomes a very important thing when talking about displacement, is you have to understand, well, how did you set up your coordinates? Because that is vital to understanding what do you even mean by displacement. Displacement is not the same as distance traveled. Okay, so imagine someone standing right here and they walk over here and they walk a distance of 12 feet. Okay, so the displacement is 12 feet. The distance traveled is 12 feet. But if this person walks over here a distance of 12 feet and then they walk back a distance of 4 feet, the displacement is 8 feet. The distance traveled is 16 feet. So in this case, delta x is going to be 8 feet, whereas the distance traveled is going to be 16 feet. So this is the, I guess we call it L for the length that you actually walk, so the distance traveled. So these are different quantities right now. And so do not mix up displacement and distance traveled. The Indy 500, famous race. Normally it's held at Memorial Day. This year they've pushed it back because of the COVID-19. So it's going to be held at the end of the summer instead of the beginning. 500 miles is the distance that the cars travel. The displacement is 0 because they start at the start-finish line and they end at the start-finish line. So that's the difference in displacement and distance traveled. They're not the same thing, not for physics and engineering. So this is the basic idea that we have here for displacement and the basic idea for distance traveled. Okay, so the next topic that we're going to discuss is the rate of displacement. The rate of displacement is velocity. And so that'll be the very next topic.